All right, you're doing great. Now let's take a look at slopes of parallel and perpendicular lines. Parallel lines are two lines that are right next to each other, never going to touch. Perpendicular lines are lines that cross and make a right angle when they do. So parallel lines have the same slope. So for instance, y equals 3x plus 2 and y equals 3x minus 10 are parallel lines. They have the same slope. They're both 3. It doesn't matter about the y-intercept. That doesn't really help us determine anything. All we're looking for to figure out if they're parallel is what the slope is. Y equals 3x, so that works. So here's a couple more that are parallel. 4x plus 11, y equals 4x minus 2, y equals 10x plus 5, or 4, y equals 10x minus 3. You could keep going. Notice that I have these two are parallel. These two are parallel. They have the same slope. Those ones are pretty easy. Perpendicular lines are perpendicular if they have slopes that are negative reciprocals. Now we already learned what a reciprocal is. The reciprocal of 1/2 is 2 over 1. The negative reciprocal of something is if this is a positive 1/2, my answer becomes negative. It flips the sign. So for instance, the negative reciprocal of 3/4 is negative 4 over thirds. The negative reciprocal of 10 is negative 1/10. The negative reciprocal of negative 3/2 is positive 2 over 3. Okay, so you flip it, and then if it's positive, it becomes negative. If it's negative, it becomes positive. So an example of some equations that would be perpendicular would be like y equals 3 over 2x plus 10 and y equals negative 2/3 x plus 14. Again, the y-intercepts don't really determine anything regarding perpendicularity. That's a word. But you only look at the slopes. 3 over 2, negative 2 over 30. They're perpendicular because they're negative reciprocals. Last page of this lesson. So let's take a look at some parallel lines and perpendicular lines. I'm going to take two example parallel lines. Y equals 3x plus 1 and y equals 3x minus 3. So we know they're parallel because they have the same slope. So the first one I'm going to graph. I'm going to identify my m and my b for each. My m for the first one is 3 and my b value is 1, my y-intercept. For the second equation, my m value is 3 again, but my b value is negative 3. Now because I'm going to graph both of these on the same plane, same coordinate plane, I'm going to label this y1 and y2. So that's my way of denoting the difference. So the first one I'm going to plot by going up 1, my y-intercept is 1, and then my slope is 3. So it's rise 3, I'm going to put 1, 2, 3 over 1. Okay, again, I could have gone left 1 and down 3. And I see that this is my line. And with a straight line, it would look something like this. I'm going to label it y1. All right, now let's graph the second one. Y equals 3x minus 3. So the first thing I'm going to do is plot my y-intercept, 1, 2, 3. And then I'm going to do my slope, 3 over 1. So rise 3, 1, 2, 3 over 1. Rise 3 over 1. Rise 3 over 1. Now when I connect it, I see that I have parallel lines. And if you look at the points, they're the same distance apart. Okay, so check this with yours. Do a straight line with a ruler maybe, and you will see that they are parallel. Now let's take a look at some perpendicular lines. How about y equals 1/2 x plus 4. That's going to be our y1. Oh yeah, I should have labeled that y2. And then our y2 is going to be y2 equals negative 2x plus 1. So negative 2x plus 1. So let's identify our slope and y-intercept. I'm going to use this space here. My y1 was 1/2 x plus 4. So my slope is 1/2. My y-intercept, is 4. My second equation is y2, which equals negative 2x plus 1. And here my slope is negative 2 over 1, and my y-intercept is positive 1. I know they're going to be perpendicular because this slope is 1/2, this is -2. So 1/2 and -2 are negative reciprocals, one's positive, one's negative, and they're flip of each other. This is really 2/1, like we see here. All right, plotting the first one. We have a slope of 1/2, y-intercept of 4, so I go up 4, and then I go up 1/2. My rise is 1, my run is 2. So my line here is going to look something like this. Okay. Now my second one, I can label that y1. My second equation is y2, which has a slope of -2/1 and a y-intercept of 1. So I go up 1, put a point. My rise is -2, so down 2, and then over 1. And I can keep doing that, down 2, over 1, down 2, over 1. And here, when I connect, my two lines are perpendicular. They make a right angle. So there we have perpendicular lines. On the left side, I could show that these two lines are parallel by writing something like this. y1 is parallel to y2. This is a sign for parallel, two lines that actually are parallel. And notice, it's right in the word, right there. Okay. For this one over here, I could write two lines are perpendicular. y1 is perpendicular to y2. This is a symbol for perpendicular. It's an upside down T. Okay, because it makes a right angle. Some people said, well, maybe you just make two perpendicular lines, but what does that look like? Plus sign. So we don't want to do that. Instead, upside down T. It still has that look to it. Okay? All right, example 3. We're almost there. Find the slope of a line, singular, that has the given relationship to the line with the provided equation. So the first equation, again, not in slope-intercept form. So I'm going to get it there. Subtract 4x, subtract 4x. 3y is equal to -4x plus -18. So there's negative. Divide every term by 3. Those cancel. Y is equal to -4/3x plus -6. There we go. All right, my actual slope here is -4/3. Parallel lines have the same slope, so that's also going to be -4/3. And perpendicular lines have slopes that are negative reciprocals. So this is negative, so it's going to be positive, and then I flip it, 3/4. There we go. We found the slope of each of our lines. Y-intercepts can be anything. All right, let's try y equals -3x. That's it. There is no b value, so really this is a slope of -3, a b value of 0, but the y-intercept doesn't really matter here. We're only looking at the slopes, and it is in y-intercept, slope-intercept form, function form, so we're good to go. My actual slope is -3. My parallel line slope then is going to be the same thing, -3. My perpendicular line slope is going to be 1/3, because that's the flip. This is 3/1, 1/3 was negative, now it's positive. All right, last one. Again, I need to do some manipulation of the equation first to get it into the correct form. -5y comes down, -2x plus 15, because they're not like terms. Divide everything by -5, and I get, because those cancel, y equals positive 2/5x plus -3. It's 2/5 because the negatives cancel. All right, my slope is 2/5, my actual slope. My parallel line slope is also 2/5, and my perpendicular line slope will be -5/2. Nicely done, ladies and gentlemen. All right, we'll see you in the next lesson.